Well, good day, everyone. Thanks for joining us today. I'm Gary Lapointe. I'm a professor of practice in supply chain management at Syracuse University. And this discussion today is part of the 71st Annual Salzberg Award and Lecture Program. And like most events this year, this program will be virtual. And this is actually the first in a series of webinars that will take place over the next several months. Our next discussion is going to take place on December 8th. And we have another one planned for February and another fourth planned for the end of March. We'd like to mention that this year's Salzberg Award was fittingly awarded to the supply chain professional, given all of the supply chain related issues that needed to be dealt with during the pandemic. We felt this was most appropriate this year. So we have a very interesting presentation on moving from supply chains to demand chains. And it's going to be about next generation RFID technology that takes near field communications to an entirely new level of capabilities. And I think you're going to be pretty impressed with this new technology. And it's going to create a lot of new applications for RFID. And what I'd like to do now is introduce our moderator for today's discussion, Michael Belfiore. Michael is a journalist who writes about emerging technologies for Bloomberg and for other publications. And so with that, Michael, I'll turn this over to you.
Thanks very much, Gary. It's great to be here. You know, in my career as a journalist, I tend to focus on technologies that I think have the potential to really change the game in their industry. And this is what I think of as science fiction coming true. I've had the good fortune of covering the early stages of commercial space flight, self-driving cars, surgical robotics, a lot of other breakthroughs that I really think have the potential to radically change the way we live, work, or play, or in the process of doing so right now. And the topic of today's discussion fits squarely in that category for me. I'm really excited to participate in this discussion and introduce to you, if you don't know about it already, this new technology that I really think will change the game in supply chain. We're going to get some input from our panelists on that and how exactly it'll happen and the way it works and some speculation about the future. First, I'll just give a brief introduction to all of our panelists. First, we have Steve Statler. He's the Senior Vice President at Wiliot, makers of the world's first computer that fits on a sticker costing less than 10 cents. Now, this isn't a fly-by-night operation. They have $75 million in investment from people like Amazon, Qualcomm, PepsiCo, Samsung, Avery Dennison, among others who will be represented here today in this discussion, Avery Dennison. And still with only 50 employees. So this is my sweet spot. I love to get in on the ground floor of technologies like this that are really, I believe, will really take off the next few years. So look for them to grow much larger. Now, if it sounds like science fiction, it isn't. It's absolutely real. And if it sounds like maybe it's revolutionary, you might be right. So next up, we have Amir Koshniati. He's the head of NFC business at Avery Dennison. What that means is he's head of radio frequency communication at one of the, well, actually the biggest RFID tag maker in the world, one of the biggest pressure sensitive tags, sticker manufacturers in the world. And the company did $7.1 billion in sales last year, and they employ 30,000 people in 50 countries. So, you know, these aren't small potatoes either. Next up, we're going to talk with Robert Schmid. He founded and continues to lead the IoT practice at Deloitte. And what that means is he's head of the practice of turning just about everything around you into an independent node on the internet at the largest professional services network in the world. So really going to be interested to hear what he has to say about this technology. And now everyone's going to have a chance to weigh in on this topic, next generation tech potentially revolutionizing supply chains and everything from healthcare to manufacturing and retail. And first, we're going to start with Gary Lapointe, who you just heard from. He's professor of supply chain practice at the Whitman School of Management at Syracuse University. And he's been my reality check on supply chain related innovations for a number of years now. So he's the guy I go to when somebody comes up with some new technology or innovation and it looks like it could really change things. I like to go to an independent expert and, hey, is this real or is this smoke and mirrors? What's going on here? So he's the guy I go to, and he's the one who's going to first give us the context of why this is important and where it might go from here. So, Gary?
Sure, thank you. We first heard about RFID technology. I want to say I first heard about it back maybe the early 2000s, maybe 2002, 2003 timeframe. And at the time, this was going to revolutionize inventory control for the most part. And we were going to have these little tiny tags and chips put into pretty much everything. They're going to be about the size of a grain of rice. And they're going to be able to track our inventory, keep track of where things are going. You're going to be able to walk out of a grocery store without paying, and it would automatically take money out of your bank account and so forth. And it was really hyped up, and it was going to be the latest thing, and it actually had a lot of promise. And to this day, we still use a lot of RFID technology, but it never really became as ubiquitous as I think when first envisioned. They were never able really to get the price point down on the RFID technology on the tag itself, so that it would really take hold in, like I would say, maybe low margin kind of products, like the grocery industry type products and so forth. And so the other big kind of hurdle that presented RFID technology were the readers. I mean, it required a significant investment in the reading technology. You have these gateways, archways, whatever you want to call them, to actually read the passive tags, and it had to be pretty close proximity as well. And so that was a big hurdle for a lot of companies to make that investment that really kind of would take RFID technology so is much more widespread than it actually became. And what I see here with this technology is it eliminates a lot of those roadblocks, and it provides a lot more functionality than the previous RFID technology. So that's kind of like maybe the concept, or in putting things into context a little bit.
Yeah, good. And Steve, so let's turn to you next. Tell us about this technology, why it's different, and how maybe it can overcome some of these limitations of standard RFID technology that we just heard about.
Very good. Yeah, thanks, Michael, and thanks, Gary, for the opportunity to talk today. Actually, what I'd like to do is start off, before we get into the bits and bytes, I will show you a quick demo of our version 1 product. I'll take you through a more structured review of how it works and what it can do. But before we go there, let's have some fun. And I'd like to start off with a thought experiment, a game where we all pretend to have a superpower. Now, the superpower that I have in mind, maybe not the one that you have in mind, it's the ability to see radio waves. So this is kind of a reptilian vision of other frequencies than we're used to. And if you now enjoy that superpower that you have, look around the room that you're in, what is it that you see? Maybe as you look at your phone, you can see Wi-Fi and Bluetooth and cellular signals spilling out from that in all kinds of colors. If you're like me, you have a smartwatch on, maybe you have a Wi-Fi access point nearby, and then look through the window and you'll see a cornucopia, a rainbow of colors coming from television, radio signals, the cell phone signals. And the point of this experiment is to just ground us all in the fact that we're surrounded by energy. We're surrounded by radio frequency energy. It's really just waiting for someone to tap into it, to use that power. And that's what Wiliot is doing. We're a semiconductor company. We make chips, and we have a small cloud service that we've developed, and we're enabling tags that can tap into that, to use radio waves as a power source to power a small computer, a computer the size of a postage stamp that can harvest the energy, that can calculate, that can sense, and can communicate securely to other Bluetooth devices nearby. Phones, Wi-Fi access points that now have Bluetooth radios, and a range of other devices. So we do believe that this is disruptive, and I'm hoping that you can see my slides now. So I've shared my desktop, which may be a slightly dangerous thing to do. But our goal is to connect everything, to move from a world where the Internet of Things was the Internet of expensive things, things that could justify a $50 radio and power source. And we believe by reducing that down to something that costs pennies, that can use infrastructure that already exists, ultimately that's where we're headed, then we have an opportunity to change the way things are made, the way they're distributed, the way they're sold, the way they're used, and then also the way they're recycled. We have huge opportunities to reduce waste, to fuel the circular economy. So before I actually launch into this slide presentation, I just want to show you a taste of what we are working on. And I'll start off with my phone. So hopefully you can see my phone's being mirrored on the left, picture of my lovely wife. This is an app that basically senses the Bluetooth beacons that are being broadcast by, in this case, I have a smart speaker, my MacBook, a whole variety of devices. So you can see it's pretty busy. I'm counting 218 different Bluetooth devices in my home. I'm probably at the top end of this spectrum because I have Bluetooth beacons and smart devices. And a few of these devices are actually Wiliot tags. Wiliot has an app, it's on the App Store. It's not a terribly exciting one at the moment, but let's go into it. And you can see that we have a few tags nearby. They're broadcasting. You can see the tag count going, the read count going up on the right-hand side, and these rather cryptic names and codes that are being displayed. But basically, this shows that a regular phone, an iPhone, can read our tags. Our tags look like this. So this is basically what a computer looks like now. This is a 3-core ARM processor with sensing and secure communication. The start of the year, we were making these individually. Now we're making them like this. So this is a roll of thousands of these things that can be applied to all sorts of products. I have tags on a pill bottle here, and also some razor blades. This is an experimental feature in our application. It actually combines augmented reality with the ability to read our tags. You can see there's some Gillette razor blades that have been recognized. And then, what I'm doing here is pulling up metadata that's in the cloud that is actually specific, not to general razor blades, but this specific pack of razor blades. Today, the information is not super interesting. It gives us the price. But in the future, we'll be able to include the temperature and the history of that specific product. So you'll be able to trace this, and we'll know basically where the product came from, who touched it. We'll have things like shelf life, and we'll also understand whether the product has been engaged with, whether someone's picked it up. So this is I mentioned that we have a cloud interface to all of this, and that's an important part of what we do. And you can see here there's a graph that's being slowly updated. It's based on this particular tag that I have on the pill bottles, and you can see that the temperature has been fluctuating. I have a little microclimate on my desk, and you can see that it's varied over the last few hours. You can also see this little display here. Again, it looks a bit cryptic. We're not an apps company, so you're seeing the under the covers, the inside, but you'll see that we detected that tag disappeared, and then that it's back again. So there was these are events. We have temperature events, and we have events that understand the presence or the lack of presence, and if someone is engaging with the product. And this is pretty important because it gives us a sense of whether people are engaging with products in the home or in the store. Imagine that on some sunglasses in in a sunglasses store, you could have these attached to, say, some Ray-Ban Wayfarers. Someone picks up the Wayfarers. You then have an opportunity to display an image and some marketing data about that product that may persuade us, if the model is sufficiently good looking, that we might end up looking like that if we buy the glasses. So maybe we buy the sunglasses. If that's something that we do at home, then if we have the sensing at home, then we can start to use it to keep track of whether we're taking our medicine, and there's other applications that are useful. So there's so many applications of this technology that we made a short video. It's less than 2 minutes. And so what I'd like to do is share that with you so that you get a little summary of how the technology works and what we're actually using it for in the prototypes that we're running now, the pilots.
Wiliot tags are multiprocessor computers that power themselves by harvesting radio waves. Wiliot tags are battery-free. They can sense and communicate securely with the cloud via Bluetooth technology, are as small as a sticker, and only cost pennies. Now we can connect everything, transforming how products are made, distributed, delivered, sold, used, and recycled. Experts see this as enabling a shift from supply chain to demand chain, a more efficient way of organizing the product lifecycle using demand signals from connected products. With Wiliot tags, we can track everything in real time, dynamically routing smaller vehicles, traveling shorter routes by delivering the right product to the right stores, targeting the right shelves, saving billions of dollars through leaner supply lines, lifting sales, and shrinking our carbon footprint. Demand signals show when products are picked up, when they're moved, and when they leave the store. All of this information about brick and mortar stores allow retailers to use the power of the cloud, similar to an online marketplace. Beyond the store, if someone loses their jacket or passport, it can be found. We can even tell when a product is being used in real time, allowing us to make sure our loved ones take their meds and everyday products are replenished as needed. We can track the temperature and identity of food from farm to store to refrigerator, enabling traceability that makes food safer and ensures it lasts longer, saving millions of dollars in waste. Join us, the people and the companies working to connect everything.
So I hope that gives you a sense of what our product's being used for. We're actually in a controlled release. And so we have about 27 projects running. And those, some of them are very practical. Some of them are longer term, far-reaching R&D projects. But the use cases in that video are based on that. As Michael mentioned, we are really fortunate in the investors that we have. They range from the e-commerce community, Alibaba and Amazon, semiconductors, Samsung and Qualcomm, carriers, Verizon and NTT Docomo. M Ventures is the investment arm of Merck, the German pharmaceutical company, Maersk, the shipping giant, PepsiCo, and Avery Dennison are an important investor, but they're also the way that we intend to sell these products. So we make chips. Most people don't want chips, they want solutions. And so our partners are important. Avery Dennison have a network of channels that allow these products to get to market and to open this up to systems integrators and management consultants. So Deloitte are really important as well because they help to guide people in how to use this new technology. So in summary, what we have is a computer the size of a postage stamp. There's nothing new about low power Bluetooth. What is new is that we've taken what would normally be on a printed circuit board and put it on a single chip. and we've increased the sensitivity, the ability to capture much weaker signals. And that allows us to go through a production process that is really an RFID production process. The other thing that's different to regular RFID is that all of our tags have this temperature sensing, pickup sensing ability, and can be adapted to understand when products packaging is being opened and closed. The other sensing capabilities are R&D projects, the one at the bottom, but this is kind of where we're headed. And a good way to think of our technology is it's a mashup between RFID, Bluetooth, and cloud technology. The tags are made using the same machines that convert NFC and RFID chips into tags. The important thing about Bluetooth is the ubiquity of the readers. They're everywhere. As Gary was saying, the cost of the infrastructure has been one of the major impediments. Now that the cost of RFID tags is really very low, it's really the infrastructure which is the barrier to usage. And we hope that by using the RFID production techniques and the infrastructure that already exists, then we can suddenly start joining up the cloud with the physical world and connecting products that previously were just not connectable. IoT has been the domain of water meters and cars and higher value products. So version 1 is what we have today, just entering mass production. It has a modest range, 1 to 3 meters, which is good enough to know what someone's wearing, what someone's standing in front of, what someone's picking up, what's on a shelf that has a Bluetooth gateway. Our version 1 product requires these low-cost gateways to read. They cost about $50. Version 2 will be accessible. We'll be able to harvest the energy from phones. We can read version 1 tags with phones today. And we hope that they'll be able to talk with the Wi-Fi access points that surround us now with a much greater range of approximately 20 meters. And this, for the solution architects in the audience, this is a way of thinking about the way the tags work. There's an energy network. We can harvest energy from lots of different sources. The chip is really versatile. It's a matter of designing the antennas to pick a frequency that we know is there. And we can actually harvest from 4 different frequencies simultaneously with a single tag. So that allows us to move from one venue to another, from a manufacturing environment that might have LoRa in it to a store environment that has maybe Wi-Fi and Bluetooth to a domestic environment where the energy source might be cellular. Whatever the reader, it could be Bluetooth lighting, a smart speaker, Wi-Fi access point. All of that information goes to the cloud, which is where it's decrypted and the access control is done. I'm sure we'll come back to that later when we talk about privacy. But let's get back to supply chains and demand chains. What does this mean to supply chains? Well, we believe that it's enabling a much faster shift from supply chains to demand chains. Demand chains is not a new concept, but essentially what it is the ability to leverage, to use demand signals, which might be the fact that a product has been sold. Understanding that information as a brand in real time is novel. Typically, brands lose visibility of the inventory when that inventory is handed over to to the retailer. In some cases, there may be EDI links and real-time links, but one of our customers sells a car part through over 100,000 dealers in the United States alone. And they get real-time information from Costco, but the vast majority of their channels are a blank. And so with a very low-cost gateway on the distribution racks they use to sell their products, suddenly they get real-time visibility of the inventory. They get inventory record accuracy at the shelf, at the display rack. And in doing that, they believe they can cut the inventory, the number of products they make by of the order of 20%. So that's a 20% saving in capital employed. It also means that their deliveries can go from a milk round where every dealer gets a visit from a huge delivery van that has 10 of everything, to pre-kitting, to just taking the products that are required on that delivery visit and just going to the places where it's required. So going to a dynamic routing, huge savings. If we can then extend into the home and into the car, into the places where these products are used, we can get a sense of when replacements are required. And that really allows us to crack the code in terms of moving from forecasts, intelligent guesses, to a demand chain that's informed by real-time demand signals and a continuous real-time view of where the inventory is in the supply chain. So there's many, many use cases. We don't have time to go through all of them, but the underlying trend is a shift to serialization, going from understanding the products that are in the supply chain based on SKU to every single one having a unique identity, a serial number. And that's very valuable to brands such as Ralph Lauren. They've been public about moving so that their polo, every individual polo shirt has an identity, and that enables them to detect gray market issues where the product's being sold somewhere where it's not licensed to be sold. They make a product for New York where prices are low and it gets sold in Japan. That's not good for their business. They're losing out there. It allows them to tackle counterfeit issues. And having a unique ID also is a step to loss prevention. So a product that turns up somewhere that wasn't purchased, you can understand more about that. And then, imagine a washing machine or a refrigerator that has a Bluetooth radio in it that can read these tags. In fact, you don't have to imagine it. These appliances are being made with Bluetooth in already for other reasons. And so the ability to understand how often something is being washed, what the temperature is, what the acidic level is of the food, to understand ammonia secretion, will allow us to measure shelf life in ways that will hopefully be very helpful in avoiding waste, and also giving products a second life, and dealing with recycling. So we have a furniture manufacturer as a customer. One of the challenges with recycling furniture is you don't necessarily know what's in it. And if there's a digital identity in the cloud, you can get that information and understand how to recycle it. So we just make a chip and a small cloud service that enables decryption and sensing, and solutions really require a lot more than that. And so we have a partner program, we call it Works with Williott. Avery Dennison are our lead partner on turning chips into tags. We have a whole range of infrastructure partners. HP Aruba make Wi-Fi access points. They now, as a standard, will recognize any broadcast from our tags as a standard part of Aruba OS. We have a whole set of software partners, and we have consulting partners, and our lead in that area is Deloitte. What we realized is that this technology is disruptive. Processes change, new expertise is required, and business plans and accounting gets impacted. Maybe the cost of goods goes up, but the cost of sale goes down. If companies are going to understand the value and allocate costs accordingly, typically, very often, it helps to have an external view on that. And that's why we started working with Deloitte, combined with the fact that often new integrations are required, new systems and new connections between existing systems. So that's really enough from me, I think. I'm going to hand over now to Amir, and he can talk a little bit about who Avery Dennison are and the partnership there, and how what we're doing with battery-free Bluetooth fits into a much broader set of auto ID technologies, contactless technologies that they specialize in.
Sure, and thank you, Steve, for that introduction there. So for the audience here that is not familiar with Avery Dennison, we'll give you guys a quick overview of who we are, and then we'll go into the pillars of our business before we get into the technology and the complementary fit. So as a whole, we're a global materials science company. We have a couple different arms. We're headquartered in Glendale, California, so on the West Coast. However, we have a very massive global footprint. We're in 50 countries. We employ over 30,000 employees from both from the factory side and the business side of the business. Last year, we are a publicly traded company, a Fortune 500 company. We closed the year at just over $7 billion in business. And if you look at the organization as a whole, we have three main pillars to the business. And if we can change the slide here, I can walk through those. Thank you. So we have basically our LGM business, which is short for label and graphic materials. This is where you get all of the package materials, the labels themselves, the graphics, and the reflective solutions. So many times you'll see these as the overlays that go on wine and spirits, on different goods that you may see within the grocery store. A lot that has to do with consumables and packaging. We also have our retail branded solutions as well. This has a big footprint with converting hang tags that you might see in department stores. Usually they're complemented with a converting process that has a barcode or a QR code that can be scanned. And these are really where we couple the RFID technology, usually with an embedded application that doesn't require line of sight. And then what we're seeing as emerging is really our industrial and healthcare line of our businesses. As we're kind of emerging post-pandemic right now, we've seen more and more demand here around adhesives, both for test kits, as well as where we're going with vaccines and such. So more than ever, the demand is really there for us to embed RFID behind all the different types of adhesives and medical solutions that we have. So as a whole, it's kind of a macro view of our business pillars, but RFID really goes horizontal across this. And then complementing it to Steve's introduction, our processes to really manufacture RFID are very complementary to Wiliot's technology from a chip standpoint. So the same way that we take the RFID chips and then embed them into an antenna design, manufacture them through the line and convert them to fit all these three pillars, we'll be able to do the same with BLE technology with Wiliot. So we have a world of possibility as we step into to the new era here with IoT. I think Steve, you might be muted there.
Thanks for that, Amir. Yeah, I want to get into more about your thoughts about how this will work in the real world. And Steve, you had something else to add to that?
Well, I just wanted to hand the baton lastly to Robert. So I think the whole world is aware that of Deloitte by name. So maybe just a few words to finish this off before we hand back to the panel discussion.
Yeah, thank you. Thanks, Steve. Thanks, Amir. Every time I sit here and listen to you, I get more excited, and that's hardly possible because the thought that this chip here is a computer with an ARM processor in it, and it runs batteryless is just mind-boggling to me. And it's just imagine what this can all be on. And the thing that always fascinates me about this is the ideas of what this can be on go all the way from really creepy to really super interesting, right? I mean, I'm wearing a shirt. Who knows if that shirt fits with what I'm, with something else if I wash it, right? And this is sort of like the interesting thing about this is what's creepy to you might be super interesting to me. So choice is important to me, but I just love the opportunity behind this. And even today, when we talk about it and I still have to use a gateway, there's so much track and trace with environmental variables that can be done. That's super interesting. So where we come into play on this is really taking this from a technology to a solution. Helping clients figuring out not just how the technology works, what typically falls into what people call a proof of concept. We'd like to start with a proof of value, which looks at technology, looks at process, looks at training, looks at the organization, looks at value that brings, and sort of really brings it all together into a solution. So that's what we help with, and that's what we work on with you in this area. Obviously, we do other things in addition to that. Often there might be tax credits associated, so we have a whole tax practice around this and so forth. But super excited about this. Can't wait when this is going to start actually rolling out in various use cases. I mean, I don't know. I just imagine, we talk about vaccines today, and you read about vaccines and how they need to be temperature controlled. And this measures temperature. So, what are the use cases there? What are we going to see? And, as much as I struggle at times with what's going on with us in health-wise and COVID and so forth, I don't know, the hope for me is that it actually pushes us forward in technology, and innovation such as this actually makes its entrance into useful business value and useful business processes quicker. So that's my little spiel here. Thanks for having me, Michael. Back to you asking the tough questions.
Yeah, thank you, Robert. Yeah, Steve, you first of all, I want to make sure everyone is clear that these have no batteries in them, and that's one of the innovations that makes them much more affordable than other forms of RFID. And they don't just have unique identifiers that are referenced in the cloud, but they also provide their own data as well from sensors about temperature and picking up and putting down and other things that we saw on the slide. And that gets it to another key innovation here, which is they sort of come packaged with their own infrastructure. It's one of the things that Gary was telling us that has held back RFID, that the infrastructure itself for RFID is too expensive to put on regular consumer packaged goods for the most part. We're talking usually about higher value items. Now we're really talking about realizing that potential to have everything with one of these attached. So Steve, give us a read on where exactly we are in that time. I know you're at version 1 right now, and that requires, you said, this $50 gateway to provide the energy to energize these things so that they can operate. Is that a standard gateway that I could go buy at, Staples or something like that? Or is that still a dedicated device that right now for version 1 needs to be used with these tags?
That's a good point of clarification. So I think it's somewhere between those 2 points that you discussed. This is a gateway. We don't make these. These were sold before Wiliot existed. You can buy them from a company called Fanstel online. And we're starting to work with more and more companies that already make Bluetooth devices to ensure that they work with Wiliot. And the process is pretty simple. Because we use standard Bluetooth, those gateways need to simply have a software update, and many of these devices can be updated over the air. That is kind of listening out for a packet that says Wiliot on it rather than Bose or Apple or so forth. And then the second thing is they need to broadcast out enough energy. With version 1, there's a small set of devices that do broadcast out enough energy for us to harvest. Version 2 is going to get a lot more sensitive. And so, one of the things I'm super excited about is our ability with version 2 to harvest LoRa radio waves. Now, this is a technology that many people, except industry insiders, may not be aware of. But Amazon just talked about the fact that they are turning on the LoRa radios in a lot of the devices that they sell, things like the Ring devices, that the doorbells and the cameras. And so we have the prospect of being able to harvest energy from a source that is in many, many people's homes. We're starting a project with a maker of refrigerators, and they're in a position to provide the energy that will be available inside the fridge cavity. So it will be a process of time. In the short term, over the next 6 months, then these tags will only work in very specific situations. And so we have a controlled release process. People can't just buy them. But I think over when version 2 comes out, which will be in calendar Q2 of next year, then we'll open the gates a little more. It'll be easier to get the technology. And that's really because there'll be more ways that the these tags can power themselves based on the infrastructure that already exists.
You said they could operate just on the energy from your phone. In other words, the device that has the app on it. That someone
exactly. So phones can read the tags now, but they don't broadcast enough energy for us to power a tag with it. We believe that in some cases, at short range, then phones will generate enough energy. They'll need to have an app on them that goes through all the privacy checkboxes. But we have projects that we're starting now where enterprises will have an app, and it just allows people to keep track of stuff. And people lose stuff all of the time. Individuals do. That's why you have solutions like Tile. But companies lose a lot more stuff than we realize. And that's a great source of inefficiency and waste. And that's something that we think we can help with this technology.
Gary,
I just want to.
So, yeah, I wanted to get.
I just want to build on what Steve just said, where he said companies lose a lot of stuff. I can remember working for a really big company, and in our national distribution center, we employed somebody who was his full-time job just to find stuff that was lost. We paid him. He made a lot of money, and that's all he did all day long was walk around this distribution center looking for stuff that was supposed to be there, but we couldn't find it.
Yeah.
And how revolutionary is this? So you're talking about these expensive gateways, and that the stuff you're talking about, I imagine, is for fairly high value things to find. You've got a full-time professional looking for those items. So now being able to be powered by even a small $50 gateway or going onto a phone, how revolutionary is this? How is this going to change the game, for example, in that scenario you just mentioned?
Oh my gosh! I like as Steve mentioned, I think this is quite disruptive technology. If you think about it, I mean, imagine just take a distribution center, and think this is how I describe it to a lot of my students. Go to a library, and take a book off the shelf, and then put that book someplace where it's not supposed to be. And then go try to find it. That's what it's like inside a distribution center. When you misplace, I'm talking about a large distribution center. It's to be able to find stuff, just be able to find stuff and keep track of stuff is a huge benefit in any company that's managing any kind of inventory. I think the other unique thing is, I can't remember if Steve mentioned this or not, but will this be able to tell if something has been purchased or not?
Yeah, we believe so. So by serializing, if you give a product a unique ID, and that ID is tracked as part of the inventory, then you can keep track if someone's paid for it as well. So, there's these Amazon stores with all of these expensive cameras that are tracking whether people have bought something. It's kind of it's a brilliant idea, but it's very limited in scale because this camera infrastructure is expensive. One of the use cases we're working on, we have a project that's just starting with one of the biggest loss prevention companies in the world. They work with Best Buy and retailers like that. And the eye opener for me is the industry is actually moving away from alarm bells that go off when products walk out the door. Because let's face it, do we really want our minimum wage shop employees doing a tackle on some felon who's running out the door? It's probably not worth it. The biggest issue with shrink is just knowing what's shrunk, what left, when did it leave? Mm-hmm. And it turns out, if you have that insight, shrink goes down, because actually a huge proportion of shrink is not out the front door, it's out the back door. It's employees that take that nice jacket home with them. And employees tend not to do that if you can track exactly what product left and when and who was working at that time. And even if it does go out the front door, one of the biggest issues is, okay, we lost the jacket. But the real issue is suddenly the sales go down and no one knows why. People think, oh, people are no longer interested in red jackets. Actually, people have been looking for the red jacket. It was supposed to be in stock. It's not in stock. And we misinterpret that demand signal as lack of interest, but it's actually lack of inventory and an error in the system. And so having an ability to have a real-time view of what's on the shelf, what shelf it's on, is tremendously powerful from multiple perspectives.
I
And that's
think
where you're getting into.
I just want to.
Spending. Yeah, go on.
I just going to build on what Robert mentioned. I think that one of the big challenges here is imagining all the tremendous applications there are for this technology. I mean, you can just sit and think for days where this technology can now be used, and just let your imagination go, really.
Well, I have a tagline in my photo, which is think big, start small, scale fast. And I think this is what this goes back to, right? Think of the big ideas that you haven't done, but then you got to start somewhere.
Mm-hmm.
And we always talk about start with a few small things, take them in a portfolio manner, right? Try them out. And you're not just trying out technology, but you're also trying out how people adapted, what they feel about privacy and so forth. Because one of the powers about this is, so today, if you think about it, we can go and we can stick these on product, or we can stick this on machinery or something like this, and we'll know where it is. We know temperature. We can even do things like, is a thread ripped and is a package opened or stuff like that, right? And that's all great stuff. And really, in a way, we can do that today, but we can't do it as cost effective, and we can't do it as quickly. So the imagination isn't so far out there, and I'm excited about that, right? Please don't get me wrong. The fact that I can get temperature off of this in such a small way is amazing, right? And then think about when you don't need gateways anymore, when this can be at your home. And so now think about this from a consumer products manufacturer. They today send their product to a retailer, and truly they lose connection with their product unless it's connected. So now when you have this in there, I could stick this in the back of my shirt. Excuse me, Ralph Lauren, that I don't wear your shirt, but in any case, next time I will. But what the thing is, now I can do things and I can stay connected with my customer, with my consumer, that as a manufacturer, I wasn't able to do before. And so that creates a whole new power shift. And that creates a whole new dynamic. And it's really interesting. And it creates a dynamic around who owns the data. It creates a dynamic, what can I do with the data? How can I serve my customers in new ways? And it creates a new problem for many companies, because today they do not work with the consumer directly. So therefore, there is typically a whole new organization needed. We find ourselves, when we do digital transformations with our clients, that we talk about organizational capabilities and strength, who is there, who can do what, and so forth. So I think this goes also a little bit back to IoT, and this is a team sport. We need to put a team together, and we love being the quarterback for the team. Not really good at football analogies because I'm Austrian, so maybe we should talk about soccer. Maybe we can be the captain of the soccer team, right, Steve? But it's a team sport, and it needs not just technology provider. It needs software. It needs cybersecurity. It needs project management. It needs networking infrastructure. It might even need a telecom provider, and it needs a denizen to put this into something that we can put into product. So it's a team sport, but man, the opportunity is just huge when you start thinking how the ownership changes and how you can communicate with consumers.
Robert, you mentioned earlier on the creepy factor, and then you talk about the different players that have to be involved. Is there a role for regulation here? Do we need to get ahead of this? Do you guys need to get ahead of this? Thinking about things like GDPR, and then how this might impact this technology with data privacy and things like that.
What are you asking?
You want to say? Yeah, Robert, I wanted to ask you about what you see is, you see a potential downside here. You mentioned a creepy factor, and it makes me think of data privacy concerns that governments and regulators might have. Is there, do those folks need to be at the table as this ecosystem builds out? And what is your thinking along those lines when you interact with customers who are in these regulatory environments that protect data?
So you're asking me a political question, aren't you?
Well,
I'm gonna go and answer it this way, right? First of all, I think it's important. What's that, Michael?
Just a privacy concern that folks, including customers, might have. How do you address that issue?
So, number one, I would argue it's important that you look at your users and the people who get in whose hands this comes, and really look at your use case very carefully. And you can't really look at this hypothetically. This is why this think big, start small, scale fast, three-phase approach is so important. And even in your starting small, make sure you engage with them and actually test out, what do they do with the privacy preferences you give them? Do you have enough preferences? What do they check? What do they enable? What do they not enable? And then understand why they do that. So this is really important to make that part of your rollout in your phases, number one. Number two, rules are different by country today. So we have a whole practice within Deloitte that focuses on nothing but making sure that what happens in your application, in your solution that brings everybody together, is actually legal in the different countries. So that's an important aspect to look at. And last but not least, I personally, I believe you got to give people, you got to inform them, and you got to give them the right to own their data or do with the data what they think is right. And, you know, if you give them value, if you give them some value actions and information that they can do something with, that shifts the creepiness to it's valuable. And so I think it's important for us to understand that there's a creep factor out there and deal with it through the process that are laid out.
Right, very good. I want to get to Amir in here, a question for him, and then we've got questions coming in the Q&A, so I want to make sure we have time for those as well. But Amir, I wanted to get a read from you on how this might disrupt your business. You mentioned there was in your presentation slide, you showed the two top segments of Avery Dennison's business are RFID and then these pressure sensitive labels, these stickers. How does a technology like this combine the capabilities of both, and how might that change the way you do business? Are they still going to be two separate product lines, or are you going to end up merging them together? And what does that look like for you in the near future?
That's a great question. I think as we're evolving with technology, like anything else, you get to the next era, and you get to the next era of convenience. So I'm going to use NFC as an example. Back then, you look 5 years back, 7 years back, if you would have looked at NFC technology and contactless transactions, they were slim to none. There was a data point about 4 years ago when you took the total transactions through contactless payment and compared it to the Starbucks app and what they were doing with contactless. Starbucks was much higher in the US versus all the domestic transactions. So we've evolved a great deal, and I think the pandemic has evolved the technology a great deal to start with the usability. So relying less on handing your credit card, inserting your credit card because you don't know who touched the credit card before in that point of sale solution and pulled it out and what germs you're transacting. So we're seeing an uptick in the technology. Now, as you evolve into the next era of technology and you look at it from our perspective, it's very complementary into what we're doing. If you look at our converting line of the business, if you look at our machines, like Steve alluded to earlier, you run the same machines to produce these tags and you're getting a whole new world of capabilities. Now you'll still have the legacy businesses that are dependent on RFID because they have to justify the CapEx they've done from an infrastructure standpoint. But when you look at the ease of the technology, you're actually entering a new world, a whole new era of going contactless to the point that you don't even need to take your phone out anymore. So if you're looking at the access control use cases, instead of taking your phone and actually tapping to go into a door, you can technically approach that door and the door would open on itself and give you access. And the same would work with point of sale solutions. If you get to a certain proximity, it could give you the ability to transact and keep your phone in your jacket or in your back pocket, whatever the case may be. So the ease and the adoptability is becoming streamlined. And then we're also getting into a whole new era of technology. So I think there's going to be a learning curve like anything else, and there's going to be a little bit of adoption that goes with it. But what we've seen with the evolution into NFC, I think is going to take another wave now with where we're going with BLE. So we're excited to complement what we're doing. And then at the same time, it fits very well horizontally across all the segments with the applications, which are truly endless.
That's great. Yeah, thanks for that. Yeah, it's useful to think. I always find it useful to think of a new disruptive technology as analogous to a previous one, like you mentioned, NFC. It kind of gives you a little bit of a little partial view of what's coming. Although I think what Robert has alluded to is we can't really know 100% how this is going to change things. We have some initial use cases right now that look promising, but once you introduce a new disruptive technology, you can't always tell where it's going to go. No one quite knew where the internet was going to go. It couldn't predict this activity we're doing right now in the early days of the internet. 1969, when the first connection went online. We do have some questions coming in. It looks like this one might be for both Steve and Amir. The question from Ryan is, are the tags disposable? Steve, you mentioned recycling products, but what about the tags themselves?
Yeah, the glib answer is yes, but it's actually a much more intricate question and answer than one might think. We definitely have customers that are have invested in the product because they didn't want to send a battery through the post. There was a device that would have been classified as hazardous if a battery had been there. Obviously, we don't have that. It's probably not practical to recycle our product generally, although you could put this in a hard plastic case and it would be possible to reuse. Avery Dennison have actually done a lot of work in the field of recyclability of tags like this. And so we've been working with them. And we do want to get this truly disposable or recyclable. There's a lot of elements to this simple tag. There's different kinds of adhesive that are used to attach the chip to the antenna. And what we're working on at the moment is moving to an adhesive that will basically not gum up the machines that skim and separate the different elements of a tag. So I think what we can say is our footprint is much better than the traditional alternative battery-powered devices, and we're still working on getting true disposable recycling of the tag itself. But I'm really pleased that we're working with a company that's done the R&D in that space, and that's something that we are working on.
Certainly easier to recycle something that doesn't have a battery, right? Sandy mentions that there's also value in product recalls. So not only just keeping track of inventory in a distribution center, but once it leaves the distribution center, what inventory is where. I think that's a good point, Sandy. And
yeah, I just wanted to add something to that. Oh, go ahead, Steve.
Well, so in the food area, this is, I think, a really super exciting thing. We're working on a project where from farm to shelf, this item level traceability is possible. So imagine in a packing shed, the workers are basically wearing something a little bit like this, a watch that has Bluetooth that can light up the tags. You can automatically see who touched the product and the same thing at the other end of that supply chain, what the temperature was. And so if someone does get sick, then if you can shift to serialization so that each individual item has its own identity, then rather than having to pull every single item of that sort from every single shelf, you have the ability to do recalls that are much more targeted and focused and waste a lot less product.
Right.
Yeah, I just wanted to add that the thing that's so exciting about this is that it's not just track and trace, right? It is track and trace together with environmental variables. And that just, I want us not to forget that, to have temperature with that, to be able to infer from movement what happened with it on shelves. That those are things that are very valuable that today take a whole different complexity. And so combining those two is really powerful. So thank you.
And do we have time for one more question, folks?
Yeah, let's try one more question.
Okay, good. Yeah, Gilbert mentions, and it's a good segue from what Robert just said, environmental issues that can also be a potential detriment as well. And how do these affect the tags, things like heat, cold, storms on connectivity? And some of the question I've had too, that, especially now we're seeing people working at home so much more, we're really starting to see the strain on our internet infrastructure. Will adding all of these new nodes to the internet due to that? Are going to be bandwidth problems with that, and will they be particularly acute in rural areas that might not have as much bandwidth generally? What do we need to think about along those lines?
I think Gilbert raises a really great set of questions. And again, it's easy to be glib and say it's all no problem. What we're seeing with version 1 of our product is it works really well in a set of temperatures that range from like -2 up into kind of the extremes of heat that people can deal with. So that's version 1. Version 2, one of the things, as well as extra range, is this ability to, we're basically making the clocks that keep these computers running and allow you to work across a broader set of temperatures. Those are getting a redesign so that we can survive in automotive style temperature environments and really cold environments where temperature sensing for vaccines becomes very important. So I think we're off to a good start. It is a work in progress. In terms of scalability, we've been running tests with hundreds of tags in very close proximity, and it works well. But really, this is why it's useful to work with a partner like a Deloitte, because there's a million things to think of, and we want people to be successful, and it requires a multi-dimensional view of this new world, which is, people, are we solving a worthwhile problem? Is there an ROI? But then there's all these environmental considerations, infrastructure considerations, and we want people to think things through carefully rather than feeling like this is a panacea. It's disruptive, it's revolutionary, but it requires planning and preparation as well.
Very important point. Thank you, everyone, for this amazing conversation.
So I think if we didn't get to one of your questions, we'll get back to you offline. We don't want to run too far over. I know Sandy had asked a question on how we manage security. I think we touched on that a little bit earlier, but maybe not as detailed maybe as we could get, but we can get back to Sandy on that offline. Okay, and if anyone else has any other questions too, we can get back to them offline with that also.
Excellent. Yeah, I just wanted to hopefully you can. I've tried to share the my closing slide here, which has Robert and Amir's contact details. And Robert, if you didn't notice, is actually is also called Mr. IoT. He has a Coffee with Mr. IoT podcast, which I really enjoy.
You were on.
And I was on. It was great. And
so was Michael.
We have Amir is actually going to be on my podcast, Mr. Beacon, which Robert was on. We interview people in the space of this niche within IoT. If you want more information about what we're doing, please visit our website and you can post inquiries there. And I know that Amir and Robert would be happy to follow up if you want to reach out to them directly too.
Okay, so I'll just have maybe a wrap-up comment. So we want to thank everybody for joining us today. We especially want to thank all of our panelists. I want to thank Michael Belfiore for being our moderator for today. And this webinar is going to eventually be published here on the Whitman School of Management YouTube channel. So you can go and watch the entire webinar again if you like. You can contact me if you have any additional questions directly. You can contact any of our panelists as well directly for additional questions. We look forward to having you join us for our next webinar on December 8th. We're going to be looking at the new USMCA agreement, and we're going to be comparing the differences from the old NAFTA agreement with the new USMCA agreement. And that should be a little bit interesting as well. So we want to thank everyone for joining us today. We really appreciate it. And we hope you found this webinar on this topic really quite interesting and fascinating. Thanks so much, everybody.